Hey everyone, welcome back. Today we're going to go through 1405, Chapter 2 from the book, from Kevin Revell's book. And this is basically about measurement. And I think you're going to see today that I have decided to go ahead and go through some slides that I have developed. Sometimes I think that my slides are just so much better that I would much rather just go over those. But I give you Kevin Revell's slides in Blackboard, so you can go look through those if you want. And you can decide which one you think is better. So, measurement. Why do we care about that? I thought or I found this from a website, and it doesn't have to do with chemistry, but it illustrates the point. So, if you'll just look with me at these two different statements here. Amanda found herself in the Winnebago with her ex-boyfriend, an herbalist, and a pet detective. And, alternatively, Amanda found herself in the Winnebago with her ex-boyfriend, comma, an herbalist, comma, and a pet detective. So one comma makes the difference between an awkward road trip with 2 people and a potentially fascinating road trip with 4 people. So make sure you're punctuating the story you want people to read. That's the grammar side of it. From the chemistry side, how we record things is important. So we're going to talk a little bit about how we record, and then in this case, digits, right? We're going to talk about significant figures, horror word, right? And then how do we maintain those important digits through calculations? And just a hint, your calculator is not helping you on this. So you have to figure this out on your own. So just to give you guys, let me move this down a little bit of help if you want additional help. You can always find crash course videos on the topics. You can find other chemistry specific YouTube lectures that are really good. They get millions of hits. I presume they do a better job than I do. But again, I think I've already mentioned this last semester, people indicated that they would rather I just go through the slides that we have for the book. They'd rather I do it, and I'm the one giving the tests and such, so they found some more significance there. But you can always find other videos. This is a good one to watch on measurement and such. And anyway, I'll leave that there for you, or you can just peruse YouTube at your leisure. So as continuing the motivation section, if you guys will take a look at this picture, what would you say the height of this block is? So assume that you started the ruler at the bottom of it at 0. And what would you say the height of this block is? The first thing you can notice is that rulers give you 2 different units to measure from. This would be inches on this side. And I'm just going to go ahead and encourage you, always just deal with metric units. So much easier to deal with metric units. One thing about it is these little lines here are not tenths of an inch, right? And that makes it much more complicated to figure out the number and the number of significant figures. So if we look on this side, we see there's some additional lines here for 0.1 centimeters. These are centimeters here. But you can look at it and see, the block itself is kind of in between these 2 lines. How do we want to measure something like this? And this is how we're going to do measurements. I'm going to go through real quick how we do this, but it's important for several reasons. And let me just illustrate a couple of those points here. So if we were looking at this and we looked at the inches side, which again I don't recommend that you do, you'd see that it's kind of like on the line for 8 3/8 of an inch. Well, how are you going to write that down? Are you going to say 8.375, right? This is just what you would get if you divide 3 by 8. 8.375, is that accurate? Is that true to the actual precision of the instrument? Well, what about 8.375 right? Obviously, I hope you can see that this is a problem. Something like this because it's just implying way more precision than we have for this instrument. You're kind of like lying, all right? Don't be a lying liar when you're writing down your digits. This would be a problem. And this itself is also not actually correct in how we want to do this. But again, just trying to motivate this a little bit for you more. And why is it going to matter? Well, there's a lot of reasons why this matters. Rounding errors and being accurate in how we determine things. But just for now, just try and stick with us. Why do we care about this in chemistry? Well, chemistry is the scientific study of matter, and then science is based on empirical evidence. All right, empirical evidence. This means that we observed something, or we did an experiment, and we measured something. And for that, we are going to be really, really concerned like 90% of the time, right? Sometimes qualitative is important, but for most of the time, quantitative data are what we are concerned with. Quantitative, quantity, right? It deals with numbers, and then also, the inherent accuracy or inaccuracy of those numbers. Okay, so this is why we care about how we're going to record digits in the first place, right? Because we're going to be dealing with quantitative data. And just going back to that for a moment, sometimes we'll come up with data, and the accuracy of that data is not sufficient for us to draw any conclusions, or sometimes that data will contradict some other, maybe another theory, hypothesis, but the accuracy is not such that we can actually use that data. So it's important, right? It's important in determining the accuracy of our measurements, and then for you guys' sake, communicating it on paper and then carrying those significant digits through calculations. Okay, first off, we're just going to talk a little bit about scientific notation. I hope you've already seen this before. If not, that's okay. And for scientific notation, the basic idea is sometimes we're going to have really, really large numbers, and sometimes we're going to have really, really, really small numbers. And we need to be able to deal with those efficiently. All right, we don't want to do like .000000000. Just gets a little bit cumbersome. Easily and efficiently, right? And then also a way that preserves our significant digits. So scientific notation is what allows us to do this. Scientific notation, for instance, would be this number right here. This is the number of atoms or molecules in a mole, which we'll get to later on in the semester. And you can see it's written in scientific notation. So you have the coefficient, or it's called the number part. This is related to the measurement, and this gives you the significant figures on that measurement. And then you also have the exponent part. Sometimes the coefficient is called the significand. All right, I'm never going to call it that in class, but just put that in the back of your brain somewhere. This is the coefficient or the significand. And then the exponent part is just telling us some information about the magnitude. And since we do times 10 raised to an exponent, then that exponent is really just moving the decimal around. Okay, and you'll see it's pretty easy to do. So this is a positive exponent, so that means we're going to move the decimal place to the right. It's making that number bigger. If it were a negative exponent, we would move it to the left. Okay. Again, I hope that's a review for you. Again, just a quick review on how exponents work. I know it may have been a long time since some of you guys have done math. It's okay. This is how powers are going to work for you, and how they work mathematically. Something to the first power, it just gives you that number. Okay, and then squared or any higher numbers, it's just this number multiplied times itself, however many times that exponent is. Okay, so 10 squared is 10 times 10, and that's 100. And then if we have negative exponents, then basically you're just putting it 1 over that number. In this case, 1 over 10. All right, 10 to the negative 2, again, it's just 1 over This was 2, so it's 10 squared on the bottom. So 10 times 10 again is 100. This is how powers work and for those exponents. And then for the purposes of our scientific notation, if it's positive or negative, it's really just telling you which way to move the decimal. Okay. For numbers greater than 10, the exponent is a positive integer. For numbers less than 1, the exponent is a negative number. Okay. And remember, any number raised to the power of 0. Right? Do you remember what that is? In classes, I get a chance to get some feedback from students at this point, which I can't do. But 10 to the any number raised to the 0 power just gives you a 1. Okay, remember that. What about numbers less than 0? Well, if the number itself is negative, then that negative sign has to go before the number itself. So again, on the scientific notation, you'd have a negative over here if that number were negative. That doesn't change how we move the decimal around over here. Okay. So, I've already mentioned this. Sometimes we'll have to deal with really, really huge numbers, right? Like Avogadro's number. Maybe you're dealing with the speed of light, right? 10 to the 8th power. We don't want to write all these zeros, right? It's going to save us some work. And then also really, really, really small numbers, right? Like on the order of an atom or a molecule, you have like 10 to the negative 10 meters, right? Really, really small. Scientific notation is going to help us deal with all of that. So again, a little bit more review on this. If we want to convert something from scientific notation to the decimal, you just move the decimal based on the power and the exponent. So 2.7 times 10 to the 3rd, we're going to move this, since this is positive, we just move it over 3 places. 2, 3. So that's going to be 2,700. 8.314 times 10 to the negative 8, that's a negative number, so we just move that to the left 8 places. Okay. Same thing, if you want to convert from a decimal to the scientific notation, then you kind of have to do that in reverse. So since I'm moving this one to the right to get it to the number itself, right? And we always put the decimal after the first non-zero digit. Okay, and then you just keep track of how many times it moves. So this was 1, 2, 3, 4, 5, 6, 7, 8, and then it would be 5.5 times 10 to the negative 8 because we had to move it this way. And this is the idea you can get is if this number is really small, then that's a negative on the exponent. A large number is you're just going to move it back to the left here, and this is 3, 6, 9, so 6.33 times 10 to the 9th. Okay. So a little bit of review on how to do scientific notation. And getting back to our uncertainty and how do we do measurements. So all measurements are going to have some degree of what we call uncertainty based on the measuring device, based on the markings on the device and such. Okay, I'm going to give you an example of what this second sentence means in just a minute, but in chemistry, the standard is to record all of the certain digits which are read directly from the scale or the measuring device, and then one estimated digit. Okay, you're like, I don't know what he's talking about. It's great. I'm going to give you some concrete examples here. Don't worry, but just remember, you record all of the certain digits and one estimated digit. All of those numbers become part of the significant figures from that measurement. So all of the certain digits and one estimated digit, all of them become significant figures, even the estimated one. Okay, how does that work? Here are 2 different measuring devices. On this one, we have a marking for 30 and 40, and then also sub-markings for every one. This is on millimeter scale, so a marking for every 1 milliliter. Okay, those are the certain digits. All right, so we're going to record all of the certain digits just as you would normally. So in this case, it goes to 38, right? So 38 are our certain digits. And then we estimate between the last markings, and that's our estimated digit. Still one of the significant figures, but in this case, The ones place to the left of the decimal is our last certain digit, and we're going to estimate to the tenths place. So we're estimating to the tenths place on this one. So this measurement, properly recorded with this measuring device, would be 38.6 millimeters. And that last one is estimated, okay? You could get a different number than your lab partner or from somebody else, and that's okay. The important part for the class, for lab, for science in general, is the number of digits that you got here. Okay, so I have 3 significant digits here, and that's the really important part, not whether you got this one as 38.6 or 38.7, whichever one you saw. Okay, so you would never be graded on that, you'd be graded on the number of digits. Whereas this one, let me move that over a little bit there. On this one, we have a marking for every 0.1 milliliter. All right, so that means the certain digits are going to go all the way to the tenths place after the decimal, right? And then, so you have, again, it's kind of opposite here. It's 38.1, 2, 3, 4, 5. It's past the 0.5 mark. Again, on a burette, you read these upside down. Don't need to worry about that too much at this point. So it's 0.5, but it's in between 0.5 and 0.6, and so we estimate on there. I have markings for 0.5, right? So that's a certain digit, and then my last one is the estimated digit, which goes in the hundredths place. Okay, so again, 38.56, right? It's around 6, and the important part is that I have 4 significant figures here. It could have been right on the line, right? In this case, I would have added a 0 there to say 38.50, and that would have been a significant figure put in there. So then in that case, the 0 is important. Okay. All right. That's how you record from instruments. I don't know if that was very quick. I can't look at your faces and see if everybody's confused. But if you need to, go back and look that over. Read through the textbook. Make sure you get down how to record with instruments. You need to know how to do that for the class. Okay. Now we're going to talk about sig figs. Abbreviate significant figures as that. And actually, I'm going to go ahead and cut this video off, and we'll do that in part 2. Okay. All right.